Have you ever wondered how the processor on your computer or smartphone works? There are many different types of processors out there, but today I'm going to talk about the most popular processor type in the world, and that is ARM. And I'm also going to explain what ARM is, how it works, and how it compares to other processors like x86 and x64. Before we dive into ARM, let's talk about processors in general. A processor is the brain of your computer or smartphone responsible for executing instructions and performing calculations. Different processors use different architectures or ways of organizing and executing these instructions. ARM processors are the type of processor architecture that are used in a wide range of devices from smartphones to servers. They're also known for their power efficiency, which makes them ideal for use in mobile devices where battery life is a key consideration. In this explanation, we'll dive deeper into the details of ARM processors, how they work, and how it compares to other type of processors like x86 and x64. ARM processors are based on a technique called the reduced instruction set computing, aka RISC. This means that they use a simplified instruction set which makes them faster and easier to manufacture than other types of processors. The reduced instruction set also make the processor more efficient as they require less power to execute instructions. And ARM processors are also made up of multiple processing units, each of which can execute instructions simultaneously. These processing units are called cores, and the number of cores in an ARM processor can vary from 1 to dozens. The more cores a processor has, the more tasks it can perform simultaneously, which makes it faster and more efficient. ARM processors are designed to be highly configurable, which means they can be customized to meet the specific needs of different devices. This makes them ideal for use in a wide range of devices from smartphones to servers, as they can be optimized for different types of workloads. And one of the key features of ARM processors is their power efficiency. ARM processors are designed to use very little power, which makes them ideal for use in mobile devices, where ARM processors are known for their scalability. They can be used for devices ranging from small microcontrollers to large servers, and their performance can be scaled up or down depending on the needs of the device. This makes them ideal for using devices with varying performance requirements, and this could also be it is very customizable. Let's say Samsung wanted a specific type of processor, they could customize it according to the need. In contrast to ARM, x86 is the type of processor architecture that is used in many desktop and laptop computers, and of course with the exception of the Apple Silicon Macs, and a lot of you guys don't know this, but there has been taken multiple attempts on the Windows side as well, because one of the failed prime examples is got to be the SQ2 chip, which is found in the I think it's manufactured by Qualcomm, and which is found in the Microsoft Surface Pro X. It's basically a lost project, don't buy that. But that's not the topic of today's video. So x86 processors are generally more powerful than ARM processors, but they also use more power and generate more heat. And x64 is a newer version of x86 architecture that is used in many modern computers. It is similar to x86 in many ways, but has some key differences that make it more efficient and more powerful. So how does these three architectures compare? ARM is generally more power efficient than x86 and x64, but it is also less powerful. x86 is more powerful than ARM, but it uses more power and generates more heat, and x64 is similar to x86, but it is more efficient and powerful. It's basically like the middle child. With exception to the Apple Silicon Macs, of course, because the M2 chips are freaking powerful. x86 chips do not compare to those chips in the same price range. So yeah, that's an exception, and I'm super optimistic about what's happening, and I hope Microsoft catches up. Thanks for watching.